Hi everyone. In this video, we're going to look at Pandas. Pandas is a Python library that provides fast, flexible, expressive data structures that work with relational data that we'd find in an SQL database or in a spreadsheet-like form. It aims to provide kind of a fundamental, high-level building blocks that we can use when we're working on either data analysis or, in our case, machine learning. So the data structures Pandas has allows us to manipulate tabular data with heterogeneously typed columns. Heterogeneously typed simply means that one column can be string data, another column can be floating point, another integers. So it's heterogeneously typed columns. It also supports ordered and unordered time series data. So often we're looking at data that relates in time. So we might look at a server log, things like temperatures throughout a year, things along those lines. And it also allows for arbitrary matrix data. So it's a very powerful, has a set of very powerful data structures. It handles missing data well. It has this thing called not a number, both for all types of data types. It's size mutable, meaning that we can add columns to their data structure very easily, in fact. It allows for data alignment, so we can take two data structures and combine them. For example, we might have a data structure representing information about states and another one representing very different information about the states, and we can combine them into one data structure. And really important for our case is it provides a set of really high-level I/O tools for loading data. Often data for machine learning and other data science tasks are in what's called comma-separated values, and Pandas allows for quick loading of that, quick manipulation of that data. So that's the high overview of Pandas. So let's get started. Hi, so here we are in Google Colab, and like before, there's an associated Python Jupyter notebook that goes along with this video, and we can get to it by clicking GitHub here, typing in our URL. That's this one, Zaharsky ML class, and it's this intro to Pandas. So let me just copy that URL, paste it in there, and as before, here's a notebook that you can work through. And I'm not going to go through this notebook. What I'm going to do is kind of do a parallel notebook just so you get two angles to this information. So that's my goal. So let's get started here and looking at Pandas. So Pandas, as I write here, was developed by Wes McKinney in 2008. He was working for, I think, some investment firm or something, and he just wanted to make it easier to deal with tabular data. In Pandas, there are several conventions we use for importing the Pandas library into Python. And one of them is this from Pandas. So series and DataFrame are the two main data structures in Pandas, and we use them so often that we import them this way just to make it easier. The next, we'll just load all of Pandas and call it PD. So that's the import convention. So we normally do series and DataFrame like this, so we can just use them as is. And then the rest of Pandas, we do an alias of PD. So there are two types of, or two main data structures in Pandas. There's series and DataFrame. Let's look at the series first. And that's like a one-dimensional array object that contains an array of data, just like we saw in NumPy. And we can also have data labels, and that's called an indexed. And the simplest one we can do is something like this, where let's call it series 1. And because we imported it the way we did, we can just say series. But if we didn't import that, we'd have to say PD series. But since we imported that with a from, oops, my parentheses are bad. And I can say S1 here, and we see the series. So here the index is on the left, and the values at each index point is on the right. So we can get the values just by typing S1 values. And that's the array of the values. And we can just do S1 index and get that the range starts at 0 and stops at 5. We can specify an index instead of just having these auto-generated numbers 0, 1, 2, 3, 4. We can specify what we want, and that can look a little bit like this. So I can go S2 here are the values. And now I can specify the index. And there we see that instead of these numbers on the left as being an index, we have the names of the people. It's sort of like a Python dictionary, right? So we have this index and then the value at that index. And we can do the same thing. Oops, I can say S2 index, and it'll give me the values of each, not the values, the index versus values here. And when I do a Boolean operation on this, it'll preserve those indices, meaning that it doesn't create new ones, it just keeps them the same. So let me try that. So let's try to get right, so there are 3 people in this case that have values larger than 1,000. I can do operations like S2 times 2, and it'll just double those values in the index. And there's some similarities to Python dictionaries, meaning that I can ask questions like, is Faith in S2? That's true. What about Dylan? False. So that's all I really wanted to say about series. There's a lot more involved, but I just wanted to give a basic introduction to it. And let's turn to something that's a bit more common that we're going to be using, which is a data frame. So we'll look at data frames, which is a spreadsheet-like structure similar to an Excel spreadsheet or whatever we're using, or a relational database. And it consists of an ordered collection of columns, and there's a row index. So we have some idea, like what we've seen in a series, there's these row indices, and a column index. And here, one way to construct it, a very simple way, would be just to use a Python dictionary like I have here. So I have a state with this value of a Python list, and then I have a population, and I have the poverty rate of these different states. So let me go ahead and execute that. And it's called data1. Let's just take a look at it. Okay, and now I can create a data frame. Just let me call it states. Let me actually see what the value is. And there we see, so we have these index numbers 0, 1, 2, 3, 4. We have these 3 columns, and they're not all the same, right? So here we have this column of string, a column of floats for population and poverty level. So in this case, the index was assigned automatically, right? We didn't specify an index, we just went 0, 1, 2, 3, but we can specify an index. So we can do whoop. Sorry. So we have this index NM, AZ, UT in Colorado. So we can extract columns by just listing the column. Here I'll show you how that works. So you can go states, whoops. So we get the population column. We can extract two columns, let's say population and poverty. Oop. So extracting columns is easy. Let's take a look at how to extract rows. So we can use this thing called location. So I can retrieve the information, let's say, for New Mexico. So I'm going to use the index value, new NM, and I get that value back. I can retrieve the information conditionally by doing something like this. I can say states, say I want the population to be less than 5. So I get two values back, New Mexico and Utah. They're the ones with 2.2 million people in New Mexico and 3.21 in Utah. And they can be more complex than this, so I can do states. Whoop. Let me get some parentheses going here. So give me the states with a population of less than 5 and a poverty rate of less than 15%. And it returns Utah. New Mexico has a higher poverty rate than that. So that's kind of the very basics of a data frame. So let's kind of do an excursion away from Pandas for a minute to look at one feature of a Jupyter Notebook. And that is we can execute any arbitrary Linux command by preceding it with a bang. So bang ls gives us a listing of that's of our current directory. If we want to know what directory we're in, we can do pwd and a host of other things. Here's a command I did ahead of time, which is I can do a curl and just see the contents of the file at this location. And there's the results back of that file. And you can see it's a comma separated value file, right? So I have the columns. This time the file has names. So I have of the columns. So I have a name column, a sport, height, and weight. And then I have the name of a person, and then the values separated by a comma. The sport is gymnastics, comma, height 54, weight 66. So that's kind of the format of this file. So that's a real cool feature of these Jupyter Notebooks, in that you can do any arbitrary Linux command. One powerful thing we can do in Pandas is read from a CSV file. I just showed you the CSV file up here. Let's see how we can read from it. So let's call this athletes equal, and then PD is the alias for Pandas. read CSV, and we can give it a file path. That file path I'm going to copy from here. Let's see if I have it. Let me just insert another. Give me a second. Okay, and there I get the data. Now it's in the data frame. So I read it from a file. In this case, I read it from a website, and I got this information into a data frame. One interesting thing is in the original data that we saw up here, there were missing values. So you can see like Brittany Raven, we don't have a height for her. And I think there's some others that just have, there's two commas, meaning there's no value here in the middle. Same thing with Irina Mikitenko. So what Pandas does is put this sentinel, it's called not a number. So we don't have any entry for Brittany's height. We don't have an entry for her height. And I think there was another one here. We don't have what sport Amy plays. So that's a very important aspect of Pandas, and there's a number of features in Pandas that allow us to do different things with these not numbers. All right, that's great. And again, the index is automatically created. We just have numbers here. But suppose I wanted this name column to be the index. Might be a useful thing. We can do that. I can say athletes 2 equals and now here I can specify what column to use as an index. I just say index, if I can spell, column equals, and then it was the name column we want to use as an index. We don't automatically generate just a numeric index. Now the name is the index. Cool. So there's one other way we can create an index. We already have this data frame called athletes. And it just has this numeric index. So we can use this feature called set index, and I'll show you that now. So that was athletes. So we can say athletes. And now we can say what column we want to use as the index. In this case, we want names. And one option is we can say, please do this in place, meaning don't create a brand new data frame, just manipulate this current data frame. And now we see it's changed. Before it was a numeric index, and now it's these names that we're using. Sweet. Let's look how we can get some information about the data frame. So we can say athletes describe, and it'll give us some summary statistics about the data frame, meaning there were 24 entries for height that had a height value, 28 for weight. Remember that in the height there were some missing values, so that's why there were only 25 here and not the 28 of weight. It gives us the mean value, the standard deviation, what the min was, what the max was, and so on. So it's a very useful thing. When we're doing machine learning initially, we want to kind of take a little look at the data. We just don't want to enter it blindly. And these are very useful tools to give us some sort of insight into what the data looks like, how many missing values there are. It helps us make decisions then later on about what we want to do with these missing values. We can, that's the general statistic, we can give it a very specific one. We can say what the athletes, what the mean is of the height and weight of all the athletes. We can just ask it. We can get the summary statistic for a specific case. Like let's say I want so the mean value of the people who play gymnastics, their height typically is 57 inches and their weight is 87 pounds. Just for grins, let's try basketball. So there the average weight is 174. We can ask for the min values. And we're going to ask for the max values. The heaviest individual athlete in our data set is 204 pounds. Like NumPy, we can do basic subtraction, addition. We can do kind of mathematical formulas on these, on a data frame. And let me just show you that. So I can say average equals, let's just take a look what average is. So that's the average height and weight. And now I can subtract that. I don't know why I'd want to do this, but let's go just play with it. So I'll extract the height and weight columns. So there, these are all the values where I have subtracted the average. So Asuka Teramoto is 11 inches shorter than the average and weighs 55 pounds below average, and so on. Another way to do the same thing is I can do athletes. There's this subtract, which is the same as what we just did, just another way of doing the same thing. And we get the same results. Sweet. Finally, I just want to talk a little bit about sorting. So we have athletes here. There they are. And let's say I want to sort them by their name. So I want an alphabetical listing of these athletes. So I can go athletes, sort by the index. So I get the data frame sorted by the index. Let's say I instead wanted it sorted by the height. Now I get them sorted by the height. The shortest people, the shortest person is Gabby Douglas at 49 inches. The tallest person in our data set is Chen Nan, who's 78 inches. And then I get these people who weren't specified at the very end. Let's say I wanted the reverse way where I wanted the tallest people first. Let me go back here just to do it. I can say, if I can get that. Sorry. Fighting with, there we go. The reason it's doing this very wonky popping up of these tips that are obscuring my writing is that I have this resized so large, so it's legible to all you, that things are interfering. So if you were working normally, you'd get these pop-ups and they wouldn't be interfering with your writing or your typing. So keep in mind there's just a wonkiness associated with how I'm doing things here and not a general wonkiness of something's wrong with Jupyter Notebooks. It's really badly done. All right, so here I have it sorted the reverse way. Let's say I wanted to, let me find some examples here. So it's sorting by height from tallest to shortest. And let's say when there's a group of them that are the same height, here let's say when they're all the same, I want that part sorted next by how heavy. So I want the heaviest people before the lightest people. So for that I can do this. So instead of sorting just by one column, I can say first sort by height, and of all the people that are the same height, then sort it by weight. And it does so. So that's it. I just wanted to give kind of a general introduction to Pandas. This should be enough to get you started on Pandas, and it should be enough to get you started working finally to do some machine learning, which is part of the next video. So I hope all this was helpful. Thanks so much for watching. Take care. Have a good day. Bye.